Today we're going to look at adding and subtracting rational expressions, and this is the first video in a series of videos. The first thing we're going to take a look at is how adding and subtracting rational expressions relates to adding and subtracting rational numbers like 2 over 3 plus 3 over 7. So in 5th grade or 6th grade you learn how to add and subtract fractions. So let's just review the process for adding and subtracting fractions. Well, the very first thing we do before we add and subtract fractions is we take a look at the denominators. And we have a denominator of 3 and a denominator of 7. So we take a look at 3 and 7 and we ask ourselves, what is the smallest number that both 3 and 7 go into? That number is called your least common denominator. So if we take a look at the number 7, 3 does not go into 7. So the way I usually do this is I take a look at multiples of my largest number, multiples of 7, until I find one that 3 will go into. So 3 doesn't go into 7. I multiply 2 and 7 together and I get 14. 3 doesn't go into 14. And then I multiply 3 and 7 together, I get 21, and I realize that 3 definitely goes into 21, because 21 is a factor of 3 and 7. Okay. Alright, so now that we located our LCD, we need to rewrite each of these fractions with our LCD as the denominator. So how do we do that? Well, the first thing we do is we figure out what factor is missing from the denominator, and we multiply both the numerator and the denominator by that. So in our first fraction we have the factor of 3. So if we compare 3 to the factors in our LCD, the missing factor is 7. So we multiply our first fraction by 7 over 7. What is missing from our second fraction? Well, our denominator is 7 in our second fraction. So if you compare the factors of our LCD, we are missing a factor of 3 from our second fraction. So we multiply our second fraction by the missing factor. And when we're done, we multiply across the top and the bottom of our fraction. So 7 times 2 is 14. 7 times 3 is 21. And then 3 times 3 is 9. 3 times 7 is 21. Once we get a common denominator, we can write our fraction as one fraction. We have 14 plus 9. And we know that 14 plus 9 is 23 over 21. And our last step is to check our final answer to make sure we can't reduce it. Okay, 23 over 21 does not reduce, so we're good. So we're going to apply all those steps to our second example here. So let's take a look at our example, our more complicated example that has variables in it. Well, the first step that we did in our first example was to find the LCD. So I'm going to tell you for our second example that's not going to be our first step. Our first step is going to locate any polynomial in a numerator or denominator that has more than one term and put parentheses around it. Because if you don't, when we get to subtraction, there will be mistakes made. So let's take a look at our first fraction. We have a binomial in our numerator here, so I'm going to add parentheses. We have a binomial in our denominator, so I'm adding parentheses. Again, the numerator and denominator of our second term are binomials, so I'm adding parentheses. And the numerator in our last term is a binomial, so I'm adding parentheses. So let's go ahead now and find our LCD. How do you find an LCD when your denominator is more complicated? Well, you take a look at the unique factors in your denominator. Okay, so for instance, in our two fractions above, we had two unique factors. We had a factor of 3 and a factor of 7. We multiplied them together, we got 21. Let's take a look at the unique factors in our denominator here. So we have a factor of x plus 1, and it appears twice. So we know that our LCD is going to have a factor of x plus 1. What is its degree going to be? Well, we take a look at the factors in our denominator of x plus 1. What is the degree of our x plus 1? Well, we notice the exponent on the outside for both of them are 1, so our exponent here will be 1. Okay, so we're done with x plus 1. Let's walk down and find our next factor. It is x plus 5, and there's 2 of them. So we know that we're going to have a factor of x plus 5 in our LCD. Again, we take a look at the exponent, both of them, because that exponent is missing, has a 1. If it didn't have a 1, you always choose the exponent that is the highest. So if one of those was squared, your LCD would use the square instead of the exponent of 1. So we don't really need exponents of 1, so I'm just going to go ahead and erase them because it just adds more clutter to my page. Okay, so the next thing we do is we need to rewrite, now that we have our LCD, we need to rewrite each of the terms using the LCD as our denominator. So let's take a look at our first term here. We have a factor of x plus 1. Compare that to the 2 factors in our LCD. We are missing a factor of x plus 5, so we have to multiply this first term by x plus 5 over x plus 5. Okay, so now I want you to take a look at the factors of our second term. The factor that we're missing, we have an x plus 5 here. If we compare it against our LCD, the factor that we're missing is an x plus 1. So we need to multiply our second term by x plus 1 over x plus 1. And then if you take a look at our last term and compare the denominator, here we have an x plus 1 and an x plus 5. We're not missing any factors, so we are just going to rewrite that one the way it is. Our last step is going to be to multiply our numerators out and then combine into one fraction. And that's what we did up here in our example with just our numbers. We multiplied each term by the missing factors, and then if you notice over here, we multiplied our numerator to get 14 and our numerator here to get 9. So let's go ahead and do the same thing up here. I'm going to go ahead and take these terms and I'm going to distribute, okay, use FOIL, and I'm going to get, this is going to be something large, so let's squeeze it in down here. I'm going to get 2x squared plus 5x plus 10x plus 25. And that is going to be all over my LCD of x plus 5 times x plus 1. My second polynomial, let's go ahead and multiply that out. We have, and I should put parentheses around because I have more than one term. So I get an x squared plus 7x plus x plus 7 over the LCD, x plus 1, x plus 5. And then my last term is already done over my LCD. So now I have addition between these. So what I could do now is just combine like terms. How many x squareds do I have? 2x squared plus x squared, so I have 3x squared. How many x's do I have? 5x plus 10x is 15x, plus 7x is 22, plus 1 is 23, plus 5 is 28x. And then I have a 25 and a 7 is a 32, and a 17 is a 49. And it's all over x plus 1, x plus 5. Okay, so the last step is to determine whether you can simplify our final expression. So I know that, let's see, I think we can. I think we can factor this final expression. So if it's going to be factorable, 3 only has one set of factors. So let's try this out. 3x and x. And let's see what we get. 49 has pretty much 2 sets of factors, 1 and 49 and 7 and 7. I'm going to try 7 and 7. I'm going to put a plus here. If I do my outside terms, I get 21. My inside terms, I get 7. 21 and 7 is 28, so that works. And then in my denominator, I get an x plus 5. All right, so I want you to notice that once we factored our numerator, and our denominator was already factored, our numerator had no factors that could reduce with our denominator, so this is our final answer. Okay, so make sure that you always apply parentheses first, then find your LCD, and make sure that you always multiply things out, okay, and add like terms. And you are just pretty much following the same steps that you would if you were adding and subtracting regular fractions.